So I will be showing you like I have a toy application to exercise the connection. But the idea is that, you know, we have scanner adapters in Harbor, and they use Redis instance to somehow, this is kind of a work queue because we have to implement the scanner, a pluggable scanner API in a asynchronous way. So first, when we receive a scanner request from Harbor, we save it, and then Harbor is polling us. So to not block this request, HTTP request, we need to do the scanning job, execute 3V or for the 3V adapter, or call Aqua CSP scanner CLI interface in the background. So when by default, when someone is, you know, downloading Harbor installer and trying to connect, they do specify this. I'm typing just below so you can see. Sorry, I don't have any slides, but this is going to be easy. So they specify the URL to connect to the instance. They could specify username and password. Then they specify Redis instance, and then they could specify port. Maybe they could specify the number of the database, which is kind of a namespace, and that's it. But this is very unrealistic scenario, because having a one instance of Redis is not like a reliable or high available deployment. Usually what people run, they have like a master instance, and then they have one too many slaves. And what is more, master is usually in a read write mode, and from slaves, they just read. So then there was a question how to support this in Harbor. So we had to change the URL parsing in Harbor core, and then as a follow-up in the adapters. So the guys from Harbor are smart, and they said, we're not gonna change this parsing configuration and stuff. So they said, we're gonna extend the URL schema. So they say, this is not standardized. This URL is somehow standardized by the Redis folks. And then this is not standardized, but it is used by quite a few Redis client libraries. So they say, let's do like that. And they say, specify Sentinel host 1, port 1. I will explain host 2, port 2, and then master name and DB number. This is like generic schema. So one more thing about Sentinel. What is Sentinel? So when you're running Redis in a highly available environment, you also want to have, you don't want to have a single point of failure. So usually you deploy Sentinels, kind of a guards, which do manage the configuration and check the health status of master and slaves, and slaves could elect a new master in case of a failure of the master. So long story short, you do not connect directly to Redis instance, but you ask a Sentinels, which is like a quorum, to get you the connection params for the Redis instance. So basically they manage the health status of the cluster, but also they manage the configuration in the distributed environment. So this is how we do extended. So now users could pass this sort of a URL, and we will parse it. When it comes to the code, it's pretty simple, because so far we have just this code, which is very simple. We specified the endpoint URL, and I think this line is relevant. We are using Redigo library, which has a dial function, and you provide your connection parameters. So you specified, it was like an instance address. Now you have to do like two steps. First, you query the Sentinel by providing the Redis addresses. And then once you have the connection to the Sentinel, you ask it for the master address. So long story short, there's not so many changes in the upstream or in the downstream code. And we do provide this kind of a connection pooling. And I just want to demonstrate you the failover scenario on my simple app. So I do have some logs. I do have a cluster. First of all, I have a cluster up and running. It has a one master, and it has two slaves. Just let me make it a little bit bigger. So yes, I have one master, two slaves. Those are two containers because one is an actual instance and another is a Sentinel. And then I have this little application. This is an app that I used. Just I use this simple application to see, like, get all the keys to test the connection with the Redis cluster. And as you can see here, first I'm connecting to the Sentinel, and then the Sentinel returns the IP of the master. So it's, just remember, 20. And if I list the pods, this is master. It's this IP address. So now what happens when I crash this master? This is I think I could just scale it down. This master. So I should not be able to connect anymore to this master. It's terminating. Let's wait for this guy. But let's try to connect to the application again. Like, it just exposes a simple endpoint to get all the keys. It's getting errors because it takes a while for the Sentinels to elect a new master. I don't want to show you all the logs, but it's pretty nicely they're showing how they elect a new master. Hopefully it's going to work. If not, you have to imagine that it worked. I tested it. Just a sec. Where are the logs? It's just complaining that, you know, this 20 is no longer available, which is fine. But I hope that they recover. Yes, as you can see, it recovered now. So error while getting keys, and then as you can see, he now connected to 23, which means we automatically recovered. The only missing part now is just to, as you saw, it takes a few seconds to elect a new like a master. So what I need to do in a code of adapters and in Harbor is to reconnect, because it might happen that we started scanning and then there is this period and we do not have any circuit breaker implemented whatsoever in the Redigo. So, you know, we have to like rescan manually from the Harbor interface, but with this mechanism we could, you know, do it automatically. So yeah, that's all what I have for this Sentinel thing. The tricky part for me was to create this cluster, but I found you might find it useful as well. The Helm charts from Bitnami, they're a pretty powerful set of apps. And it's not just a toys, it's like a production battle-tested deployments. And this is how I found how to actually simulate this scenario and how to deploy it on the cluster.